If you ever wished your set could stay logged and unchangeable, Python already has something for that called frozen sets. Hello learners, welcome to your learning hub, the Learning Loop. I am Swati Sharma and this is the 15th video of my beginner friendly Python Go series. If you are joining me for the first time, thank you for dropping by and do not forget to subscribe this channel so that you do not miss out on any future videos. And if you haven't checked out my previous videos yet, I would highly recommend you to go back and check those out so that you are all caught up. In today's video, we are going to explore frozen sets and immutable version of sets. So without further ado, let's dive in. Let's first understand what is a frozen set. A frozen set is almost same as a normal set except it cannot be changed. No adding, no removing, no updating. Once it is created, it stays the same. Let's quickly understand how we can create a frozen set with an example. For today's example, we will be using the IDE Spider. And just in case you're not aware how we have reached this IDE, I would highly recommend you to go back and check out the video where we have covered installing Python with Anaconda so that you're aware how we can get to this particular IDE. In order to create frozen sets, we will not be using curly brackets. Let's review that with an example. Let's say I declare a variable fs and I will give a keyword frozen set in order to declare a frozen set, round brackets, and in these round brackets I can give any iterable, which means I can declare a list, a set, or a tuple. Anything that's given inside that would be converted to a frozen set. Let's say I give the list here. You can give tuple or set as well. The only difference would be these brackets. So if you are declaring tuple, it would be round brackets. Remember, it would be round brackets within the round brackets of frozen set. Or it could be a curly brackets instead of the square brackets if you want to pass the set inside a frozen set keyword so that it would be converted to a frozen set. We will see that as well. I will also cover one more other iterable to cover that example. So once we have done this, let's try and print that as well. So I will pass print round brackets and we'll give the variable. I'm going to select it and go to this I option, which is to run the selection or the current line. I want to run both of them together, so I'm going to select and run it. And if you can see here, the frozen set, once I have declared it, it has created a frozen set, and the format is it would write frozen set, give the round brackets, and within that you would have the curly brackets, and that's how you will recognize that's a frozen set. So you can also pass any other iterable. So I will write fs underscore other and then write frozen set. And let's say I'll give the set inside it. So I'll write 1, 2, 3, 4. And let's also bring this one, fs underscore other. And I'm again going to select it and run it. And you can see it has been converted to a frozen set. Remember, frozen sets are almost same as sets, except for the fact that these cannot be changed, which means frozen sets are also unordered collection of items. The items inside frozen sets do not have any kind of indexing. They are unordered and are placed in any order. These items doesn't have any order. And also, frozen set will not have any duplicate inside it, right? Just like set, frozen set would not have any duplicates inside it. So the only difference between set and frozen set is that we can add modifier of date, the values inside the set, but we cannot do the same within the frozen set. Now, if you want, you can also convert these frozen sets back to list or set or whatever you have passed within the frozen set. So let's say I say list and I want to convert it back to list, the fs1, because in fs variable I gave the iterable list. So what I'm going to do, I'm going to write list and then pass fs, and then let's print lst and check that out. It will convert whatever we had under the fs in the list format, as you can see that. Same ways, if you do it for fs other, let's say set underscore 1 or 2, whatever, and then you give set and then pass fs underscore other. That's the variable where we have created a frozen set, and like print and then write set underscore 2. Select that, run it, and you can see that it has been converted to set. Frozen set will only allow the methods that do not modify or change the data within the frozen set. Let's understand few methods that we can use with frozen set. Let's declare two sets. Let's say fs1 frozen set, and I will give the items 1, 2, and then I declare fs2 and I will declare the items 2, 3. The very first method that we are going to check is called union, which means it will combine both the sets. Remember, it is not going to change anything in the memory, and if you want to have a union of these two sets, you have to declare it in a different variable. So I will say union set, and I'll say is equal to and fs1 dot, and I'll write union fs2. So fs1, fs2 are not getting changed. We are just creating a new frozen set, which is a union of two sets. So remember, frozen sets are not getting changed. It's just that we are creating a new variable where I'm combining these both sets. And also let's print this union set. Now let's do the union. And you can see it did the union, and how it did it. It combined both these sets and kept the common value. So it deleted or eliminated the duplicates as well. If we do the union, it would be 1, 2, 2, 3. So it has removed the duplicates because sets do not allow duplicates. So on union, you can see it gets 1, 2, 3. So while we combined two items, we also removed the duplicates from it. So next method that we are going to review in our example would be intersection. Now the union would combine these two sets. Intersection will give us the common elements. So let's write intersection underscore set is equal to fs1 dot, let's write intersection and then write fs2. And let's just print that as well. Intersection set, and I am going to run it. You can see in the intersection, which means only print the common elements, which is true in these two sets. We can see we got the 2 here. And the next one, we would see the difference. Now, what would difference tell us? That what are the items that are there in the set A that are not in set B, which means if I do difference underscore set is equal to fs1 dot difference, and then I go fs2. So right now what I'm saying is, what are elements are in fs1 that are not in fs2? So that's what I'm checking. So I'm checking that I'm comparing both the sets and saying what items are not in FS2 that are present in FS1. So let's check that. In our case, it is 1 because we have 2 in the FS2 but not 1 in FS2. So I'm just checking what items are not present in FS2 which are present in FS1. Okay. And if you reverse it, the reverse would happen. It will check what items are there in FS2 and not in FS1 if you do FS2 dot difference FS1. So be mindful of how you are declaring this particular function. So if I run it, you can see it gives us 1. And if I reverse it and say fs2 dot fs1, obviously it would give us 3 because that number is present in fs2 but not in fs1. We can also use the functions, the methods, some of the methods that we use with the set as well, which is disjoint, is subset, and is superset. Let's say if we try and check if it's a disjoint set or not, we can do disjoint set is equal to fs1 dot is disjoint, and then I'll write fs2 print, and I'll say disjoint set, and it would return false because we have some common items in both the sets, and that's why we would get the false. Let's try and check one more settings, one more example that we checked with the sets, and obviously the answer would be false again because it's not a subset, because FS2 does not contain all the items that FS1 has. In fact, both the so frozen sets doesn't have that, so it would be false in all the scenarios. But let's check it, and now let's check it, and you can see it is also false because obviously FS2 does not contain all the items that we have in FS1. So that's why it's a false, but it works on the frozen sets as well. There's only one left, that's superset. I would recommend you to go back, check that out, try it out yourself and see how it works. With that, we have completed the frozen set data type. In the very next video, I would be covering the dictionary or mapping data type, and then we will cover the very last data type in Python, that's bit array data types. That would mark the completion of data types in Python, and we will start the new topic, that's operators in Python. That's it for today, guys. If you like my content, please like, share, and subscribe, and follow me on Instagram for daily Python tips. I'll see you guys in next video. Until then, happy coding!